Thanks all for joining. My name is Nikhil Chandrappa. I'm a software engineer at Yugabyte DB. I work in the ecosystem and drivers team, where we build drivers for Yugabyte DB, as well as we build ecosystem integrations for uh, other data products like Spark connectors, Kafka connectors, as well as commercial Kubernetes support, like Red Hat, OpenShift, as well as VMware Tanzu. In today's session, I want to talk about the scalable and resilient GraphQL subscriptions using distributed SQL. So we will show how we went ahead and scaled the GraphQL subscriptions to 1 million subscribers linearly, like the entire stack from GraphQL clients to GraphQL servers, as well as the database can be scaled linearly uh, on Kubernetes. Like that's the added part. So we all know GraphQL is gaining a rapid adoption in industry, right? Like from Fortune 500 customers to startups, everyone are looking to productionize GraphQL applications. And if you do a quick Google search, you will see Google Trend search. You'll see like GraphQL is the interest in GraphQL is kind of spiking. In order to get started with GraphQL, it's like super easy for UX developers, right? Like you kind of use one of the available open source GraphQL engines like Hasura or Prisma against any database or APIs, and you'll have a GraphQL. You can go ahead and using GraphQL console, you can go ahead and query the GraphQL engine. I mean, the advantages for UX developers is kind of well known. They get the autonomy for querying the data set or querying the API itself. And since GraphQL provides a strong type system, lot of filtering and munging the data on the UI layer kind of goes away. So that's how GraphQL is gaining a lot of traction with the UX developers. However, for the API developer who has to support the GraphQL servers in the production, they would want to think about like some of the scalability aspects as well as the resiliency aspects of a solution, right? Otherwise, you cannot put these applications into production in any enterprise setup. So that's why we want to see how in an enterprise, how we can build enterprise-ready GraphQL applications, right? First thing is scalability. Obviously, as in when you scale your GraphQL engine, in our case, we are considering Hasura GraphQL engine. Like as in when you increase the number of GraphQL engine connecting to your database, the database also needs to scale. So currently that's kind of becomes a bottleneck. Like it may be the connection, a number of connections that a database can handle, or number of connections along with the existing inserts or any other traffic that a database is taking. It kind of has additional traffic it has to take care of, right? Because all the metadata Hasura stores in or any GraphQL engine will store in a database. So that's why Hasura layer, the GraphQL layer becomes like the stateless, and you would need to go ahead and scale your database. The another aspect in enterprise GraphQL applications would be like the resiliency aspect of this setup, or resiliency aspect of the GraphQL applications, right? So infrastructure failures can happen anytime. So since we all are now working remote, if you have seen, there are situations where Slack kind of went down or any other application that kind of went down. If you have architected your like applications using GraphQL, like your entire stack needs to be resilient against infrastructure outages. Whether it's your database or your GraphQL engine or the load balancer where you are asking your apps to connect to a GraphQL engine. So any of those things would need to be highly available or resilient. So for this scenario, like that's why we feel distributed SQL can help. With distributed SQL, where distributed SQL kind of provides scalability as well as high availability, like out of the box. It's kind of native to them. So in Yugabyte DB itself, like I'll not go into the depth of Yugabyte features, but just on a high level, Yugabyte is a sharded database. It kind of supports distributed SQL, where you'll have additional copies of data, as well as you can scale the database linearly as and when you have more traffic. You can have live traffic and you can do live scale up without taking down your applications or without having any downtime. Those are the advantages you get moving to a distributed SQL database compared to a monolithic single node database like Postgres. So, your entire stack, what I talked about before, like from the Hasura client, from Hasura or the GraphQL client or the GraphQL engine, and even the database, all these three layers can be scaled linearly. The way we support it is for any GraphQL engine, in our case, Hasura, it can connect to any of the available data nodes, and it can go ahead and query the data node to get the results back. It's that simple. Like for a if you are very well versed working with Hasura engine, the only thing you will have to change is you'll have to give an IP address or the load balancer IP address of where the Yugabyte cluster is running, and it can connect to any of the available nodes, and you'll be able to serve your data for your GraphQL queries. So that's why we feel distributed SQL kind of provides the resiliency and the scalability requirements needed for enterprise GraphQL application. In order to showcase this, what we have done is, I'll go ahead and show this demo. We went ahead and scaled Hasura subscriptions or Hasura GraphQL subscriptions using Yugabyte DB to 1 million subscribers. So we kind of started off small. We kind of started off with like around 20,000 subscribers, and then we kind of scaled it out to 1 million subscribers linearly. I want to show how we did that, right? For this, we chose GraphQL subscription because subscriptions kind of solve many use cases, right? It automatically sends notifications to the clients. Like you can build a real-time dashboarding application. All those use cases becomes very simple using GraphQL subscriptions. So for being a database company and working with a lot of API developers, we saw these type of use cases they are looking to solve with GraphQL. That's why I wanted to benchmark GraphQL subscriptions and do all these tests with the GraphQL subscription. So these are the results that we kind of got and how we were able to get GraphQL subscribers. If you see, we started off with just an 8 node or not an 8 node with just 8 vCPU cluster for 25,000 subscribers. And we were able to scale the same database node to 1 million subscribers linearly. So we didn't have to bring down any of the clusters or any of, we didn't bring down any of the traffic or any of that sort. We could scale the GraphQL subscriptions linearly to 1 million records. So this is the entire benchmark setup. I'll go over the benchmark setup in the demo. I'll show you step by step how we went ahead and did this setup, and what all the tests we did during this, right? Like obviously to simulate the infrastructure outages. So some of the things we did is we kind of took down a Yugabyte DB node. We kind of observed the behavior of the cluster and behavior of the entire setup. Obviously, in the results, you shouldn't have any data loss or any subscriber any subscribers shouldn't be affected. So you will see how all those things behaves in this kind of architecture. This becomes very important, right? Like when you are moving to cloud native kind of a setup, your entire stack needs to scale and become resilient. That's what we were trying to show with this benchmarking exercise. Let me go ahead and show you my setup that I have currently. So I will toggle between 3 screens. Before I go to my demo, I want to show you all the work we have done. It's in our Git repo. If you want to look into how you can go ahead and replicate the 1 million subscription effort that we did, all the steps are provided in this Git repo. It's under Yugabyte repository, and you can go to Yugabyte GraphQL applications. So in the setup itself, as I said, the entire setup is running inside Kubernetes. The Yugabyte DB cluster is running as a Kubernetes, is like a 3-node or a 3-pod Kubernetes service, as well as Hasura is running inside Kubernetes as a pod itself. And also the load generators that we want to simulate this subscriptions are also running inside Kubernetes. The sample application itself that we are trying to use is it's modeled on like an e-commerce kind of a setup. where we have a user order tracking. So as and when for each user, as and when new order is coming and the status of those orders are getting updated, the user will get the subscription or a notification automatically. So that is a kind of sample application that we wanted to model this on. For that, we have a few tables that we are using, the user accounts table and the user order table. I'll show that when I get to the Hasura engine. And this is the simple subscription that we are using. If you see the subscription, all I'm saying is for each user, I want to know new orders that are coming into this for that particular user, right? That's what we are going to see here in this demo. Uh, Before that, I just wanted to show the setup. So I have a Yugabyte DB cluster. As I said, it's running on Kubernetes. It's a 3-node, which means 3 pods. We have the servers, which are the ones which will hold the data. And I have a Hasura GraphQL engine connecting to this Yugabyte DB cluster. So as I said, we'll be using 2 tables, right? Like the user accounts table. What I have already done is I have gone ahead and I have tracked these tables. I have user account table as well as the user orders table. Since it's already tracked, I can go to the GraphQL console and fire some queries, right? I'm using the same subscription query that I have. I can go ahead and do the subscription queries here. In order for our demo, let me change this from query to subscription since we are doing subscriptions, right? Benchmarking subscriptions. I will go ahead and start the subscriptions. Like as and when I'll start a data load, I'm in to simulate the new orders coming in. We should see there will be like new orders coming into the showing up in the console. Okay. And also, this is my Kubernetes cluster. If you see, I have a 5-node GKE cluster I'm using. And as I said, all the components of this setup is running inside this Kubernetes cluster. If you see, let me go ahead and quickly show you the pods where Yugabyte DB cluster is running. YB dev, it's running under this namespace that I have here. If you see, these are the pods for my Yugabyte DB cluster. And also, I have a Hasura node that I'm running. So the reason we have chosen Kubernetes is like a lot of developers and a lot of enterprises are moving towards Kubernetes. And also it's easier for us to scale our containerized workloads on Kubernetes, right? Since all of these are running as stateful sets, I just have to change the stateful sets from whatever the desired number and will automatically get scaled up. And that is like the advantage of having a cloud native setup. Like if when your entire stack is cloud native, you can easily scale out like each layer of your setup. Okay. Now I think we have, I showed you Yugabyte DB cluster, Hasura cluster, and also one other thing that we have, you can see here is a GraphQL Perf tool. So the Perf tool is obviously is part of the Git repo. This is just a GraphQL Perf tool that we have created. It's we have extended the work that was done from the Hasura team so that it can work against Yugabyte DB, and we have modeled it for our particular use case. What this GraphQL Perf tool is doing is, I have already started the GraphQL Perf tool. For now, I'm saying I want to go ahead and create 10,000 subscribers. That's what I have gone ahead and started this GraphQL Perf tool to do. You can change this from 10,000 subscribers to a million or whatever the desired number of load throughput that you want to give against the cluster. And also one other thing that you want to notice is the GraphQL subscriptions is generally modeled using live queries, right? Live queries are nothing but like queries performed against your database at a regular interval, so that they know like if there is any new data coming into the cluster or not. Since I already have 10,000 subscribers or 10,000 users that I have in the system, if I go to my Yugabyte DB metrics, I should see there is some traffic that I have in the cluster, even though I'm not doing any data load or any other simulation. Just by having subscriptions, you'll have a load that is going against your database, because that's how GraphQL subscriptions are implemented. And it becomes essential for you to take a note of this. This is like auxiliary traffic that's going to go into your cluster, apart from the traffic you will handle for reads and writes, right? So this is specific to the GraphQL subscription query. And it becomes essential for us to scale out. That's the reason we want to scale out our database as well. As in, when new subscriptions or the number of subscribers increase, you should be able to scale your database also. Okay, cool. Now as you can see, we have around 40 transactions that is coming into the system. The way Hasura works is it kind of does a batching of a bunch of subscriptions when it fires the query, so that there's like a bunch of optimizations. If you're interested in those things, you can check Hasura. They have like a bunch of really good blog posts on how live querying actually works against Postgres database, which Yugabyte is based out of, right? Like Yugabyte is also a Postgres compliant database. Now, in order to simulate new orders coming in, let me go ahead and fire this is like a sample app data generator that we have. It generates a bunch of orders now. What I'm saying is I want to generate subscriptions I want to generate like 1 million orders for all the subscribers that I have in the system. So even this load generator is going to run as Kubernetes pod. Let me go ahead and start this. And once this gets deployed, let's scale it, right? Okay, let me do there. Okay, you'll see that I'm doing some writes, some new order simulation into the system. We should see that coming in our subscriptions as well. Like, let me go ahead and do the log. So as and when new subscriptions are coming in, we are inserting this subscription back into the database in an events table, just to verify that all the subscriptions that came into the client are actually delivered or not. So in order to just verify the benchmark results, right? We want to do that. So if I go ahead and like refresh my metrics, you will quickly see that number of transactions now increase because I have new load coming into the system. And also in my subscriptions, you will see that new orders is coming in, right? I only had one order, now a new order came in. So this is the, you kind of now see the entire setup in action. You have GraphQL clients getting subscriptions, you have a GraphQL server making queries against a database, and you have the database itself, which is handling the transaction. Now, we want to do that scaling and the resiliency test, right? Let me go ahead and show you how easy is it when you use a cloud native database like Yugabyte to scale your database itself. So we generally, the things how used to you happen, right? Like you had to go and have a read replica and do a failover. A bunch of things used to happen in traditional databases. All those things is not needed when it comes to distributed SQL database like Yugabyte. Yugabyte provides like some of the automations that are needed for scaling out a database. All I'll do is I'll go and I'll say edit, and I'll say I'll increase the number of pods or number of nodes in my cluster from 3 to 5. Let me say 5. Okay, cool. From 3 to 5. So it will just automatically go ahead and I'll do a save. And if I'll go back to my Kubernetes namespace, we can see that new pods will be provisioned automatically. And without any downtime, I was able to scale out my database. So if you see my traffic, whatever the writes I was doing and whatever the subscription that was happening on the client, it doesn't get affected. So even I can go now and let's just say the pods came up, I can even still, I can go ahead and do one more thing where I can increase the Hasura layer from, like, say, I'll increase the Hasura number of GraphQL engines I have from 1 to 2. I scaled my database. Now I want to scale my GraphQL engine layer, right? Okay, let me say, go ahead and do apply deployment.yaml. I think we should go ahead and increase number of Hasura pods from 1 to 2. Okay, perfect. So you see, right, like how easy is it for us to scale out this entire setup when you have like a cloud native database. So from GraphQL engine to the database, you can easily scale out the transaction. For some reason, let's just say I have one of these pods go out. So if I go back to my GitHub repository where I'll show you some of the resiliency tests we had done on like a 1 million subscriptions. If you see here, we kind of showcase the detailed observations of what happens when a data node goes away, or when there is a failure on the data nodes, or the infrastructure which was holding that data node goes away, right? If you quickly see, we kind of simulated that by killing a T-server pod. As and when the T-server pods was killed, you'll see there is a dip in number of CPU resources of that particular pod. Obviously, the pod comes back up whenever there is, since Kubernetes resurrects the pod, right? But still, for me, for us, or like GraphQL applications which was connecting to the Yugabyte DB cluster, there won't be any data loss, or there won't be any interruptions in the subscriptions that is happening. If you see here, only like the ops kind of went down for for 2 minutes, and it kind of let's just say normalized in 2 minutes, and also the latency went out only for like a couple of minutes, so that whatever the redundant copy or the secondary copy I had in my database, the follower copies I had in my database, that get upgraded to primary. That's all it takes in distributed SQL database to handle these failure scenarios. It's kind of natively built into the database itself. That's how we were able to bring resiliency into our entire setup. If you are interested in simulating whatever I just showcased, you can go ahead and go to the setup docs that we have here. We show you like step by step how you can go ahead and simulate this entire run that we just did. This is like a good examples for you to understand how you can build a scalable and resilient GraphQL applications with distributed SQL database. Cool. That's all, folks. That's all I had for this talk. If you guys have any questions, there will be a live Q&A after this talk. You can go ahead and ask your questions. I'll be super happy to answer the question. Thank you.